Good morning, everybody. Thank you for the introduction. My name's Tom. I work at a company called Grafana Labs. Who here uses Grafana? I'm expecting everyone. Actually, let's do this the other way around. Who doesn't use Grafana? What do you use? Honeycomb. I shouldn't have asked. There was one other hand over here. Who else had their hand up not using Grafana? Go on at the back in the blue top. Ingress. What? Sorry? Ingress. I have no idea what that is. I'll have to talk to you afterwards. Okay, so we've kind of done the audience participation bit. So I'm here to talk about a system we launched 6 months ago called Loki. So Loki is a log aggregation system primarily aimed at the kind of cloud-native use cases, but I mean, behind the scenes, it will work for kind of anything. We wanted to take a very different approach to log aggregation. So we've produced a system that doesn't index your logs. And with that restriction, we've tried to still build something that's usable. We started this with a design doc. I mean, over a year ago, I wrote the design doc. It's public, you can go and see it. I like to do this for all my projects. I think it's a nice way to kind of get my thoughts down on paper. We launched it at KubeCon in Seattle, so not far from here, just over 6 months ago. It was like crazy. We never thought so many people would be interested in this kind of thing. Spent the whole day on Hacker News and got to like 6,000 GitHub stars within a few weeks or something. And since then, I've kind of just been on the road giving this talk and updating it as we build new features. So the talk's going to basically be split into three things, which is, the three things I think make Loki interesting and different. The first one's why how we've made it simple and easy to scale, and why we've basically done the no index thing. The second thing, of course, all lists have to start from zero. The second thing is very much how we've integrated the workflow with other systems, and Prometheus would be the other system. I'm also one of the Prometheus maintainers, and I think it's the best monitoring system. Contentious, maybe? Anyway, and so number three, how we've made it, well, we kind of call this airplane mode, and how we've learned from mistakes we potentially made on other projects to build like a version of the software you can basically run on your laptop. So, simple to scale. Traditional log aggregation systems tend to index the entirety of your logs. So for people who aren't familiar with this, they tend to take a log message, tokenize it up into a set of tokens, and store it in what's called an inverted index. This is also how like Google indexes the web, for instance. This makes like searching your logs really quick because you can jump straight to the token you're looking for, see all the log lines it appears in. It also makes doing some kind of maths on your logs quite easy. Like if you just want to count the number of occurrences of the word error, you can do that in the index. The problem is these inverted indexes tend to be difficult to scale, especially on fast-moving data. If you think about it, you want to take those tuples that you've built for your inverted index and write them out to your distributed log aggregation system. If you want to optimize for kind of write throughput, you want to spread those across as many nodes as possible. And if you do that, then your queries are going to have to touch pretty much every node. And vice versa, if you want to optimize for query performance, you really want to kind of focus your writes on individual nodes. That's going to give you a write scalability limit. I think, there's a lot to go into this, and, I don't really want to bash other log aggregation systems. They tend to be very powerful, give you really good features and pretty good performance, but I think a lot of people will accept that they can be pretty hard to operate sometimes. So we wanted a system where we didn't have this indexing problem. And so we achieved this by just not indexing the logs. Sounds simple, really. The problem is if you don't index the logs, there was a project by Peter Borgen called OKlog, which pursued a very similar idea of not indexing the logs, and basically just brute force grepping through the logs whenever you want to do a search. And it's a really good idea, especially as you've got like more and more computers and maybe some elastic workloads. You can just like brute force your logs. It's great. I found though that like if you don't have any way of filtering down your logs other than brute force, it can get a bit painful. So we wanted to add like a very minimal index, just something that kind of groups together like logs that come from, let's say, the same target into the same stream. So this is where we kind of started to take influence from Prometheus, and we started to model these log streams as if they were time series, using the same kind of index and the same kind of metadata that Prometheus uses to identify time series. So that's really it. Like the queries you can do look a lot like Prometheus. You can basically select a set of streams based on a set of matches. The labels and metadata you put in are things like host this is running on, maybe the name of the service, the name of the job, the replica name, the version, any labels you've got in Kubernetes, for instance, that can all go into this metadata. And the nice thing about this kind of model is that this metadata is like 6 orders of magnitude smaller than the actual raw log data. You also have some nice properties around compression, because you're grouping together all the logs from a single pipe, basically, and they tend to compress very well together. So we're easily getting kind of 10x compression on these kind of logs. And because we can specify these filters beforehand, we can reduce the search space. And this makes the kind of brute force, which you still have to do with this system, the brute force approach to finding, how many errors there were in a given time range, makes it more tractable. So that's how we kind of, in really simple words, this index, we are doing about 2 terabytes a day of logging to Loki just in our internal cluster, and the index is a couple of hundred megs. So you can see it fits in RAM, right? There's really no scalability challenge with the index. So that's how we've kind of tried to make it easy to scale and easy to operate. And I could go into more details, like you can come and ask me afterwards. We've built on an existing project called Cortex, which includes things like DHTs and gossip and all of the usual stuff. So that's kind of the underlying distributed systems algorithms we've done to scale, but you've probably seen a million talks about how DHT works, so I won't bore you with those details. What I will talk about is how we've taken these concepts and how we've tried to integrate them with the rest of the tools we use. So I used to be an SRE at Google. I've been on call for, 10 years now. And this is the kind of workflow I ended up doing over and over again, day in, day out. I'd get an alert, probably not on Slack. I've got like 1,000 unread messages on Slack, so I don't really read that anymore. But I get an alert through PagerDuty. It normally, if best practice, it normally linked to a dashboard. And then I'd go into my Grafana instance and I'd kind of use the dashboards to try and figure out what happened. But most of the time, the dashboards were built from a point of view of everything's working, and obviously never presupposed this particular failure mode, or else we would have made the software not fail in this way. So the dashboards aren't necessarily always the most helpful thing. They might help you narrow down perhaps the service or the host, or give you some idea. But generally, what I found I would have to do is click on the little dashboard panel, copy out the PromQL expression into the Prometheus editor, which is the third step, fiddle with it, change the query to help me focus more in, maybe explore the data a little bit. And then finally, once I've isolated maybe the replica that's causing the issues, metrics are great, but they're not going to tell you the exact error message. That would be too high cardinality to include in your metric system. So generally, I always found myself having to go to a log aggregation system. This is Logly, I think, which I used a few years ago. And again, I'd have to copy that query in, I'd have to translate it into Logly's query semantics, and use that to kind of isolate and find the log messages for the error that I'm looking at. And, distributed tracing is cool as well. So what I really wanted to do was optimize this workflow and get rid of a lot of these transitions, or at least make them really easy. So that was my motivation. Those who are familiar with Prometheus will have seen this slide before. Prometheus has a really simple data model. This will all make sense. I'm jumping around a little bit. Where these identifiers are just bags of key value pairs. So, the key value pairs, this metadata, would be things like the instance name, the service name, the host name, the container version, you name it, anything you want to do. It might be the team that's looking after it. It might be some instructions on log levels and all sorts of things. You can put basically anything into this grab bag. A unique set of identifiers, a unique set of labels identifies a single time series. So you end up with, and a time series is just an indexed stream of numbers, basically. So in Prometheus, timestamps are milliseconds, values are float 64s. So super simple. Prometheus builds this metadata by talking to a service discovery system. And so we've got integrations with a whole bunch of different systems. I'm mainly from the Kubernetes world, so your Prometheus server in Kubernetes will talk to the Kubernetes API server and ask it, what pods do you have available? It will then run the metadata it gets back through a set of relabeling rules. These relabeling rules kind of help you express your opinions about how you want to think about your infrastructure. And then it produces effectively a set of these target labels, goes off, scrapes the services, and adds these target labels to every metric. Now, the reason I'm explaining this is because this is basically what we do with Loki. But first, I'm going to I want to talk about relabeling, but no one wants to talk about relabeling with me. It's also really hard to explain. It's kind of maybe the more esoteric bit of Prometheus. So the best example, I mean, this is the slide, right? I couldn't think of a decent slide for this. The best example I can give for relabeling is, been running Kubernetes for a while now. We like to mix the dev, staging, and production workloads in the same cluster. We just like to separate them out by namespace. We take a kind of, I know ephemeral clusters and spinning them up and down on demand is very popular. We take the exact opposite approach. So we have like nice, long-lived clusters, geographically located, and tend to be very big. What we found the failure mode was that people would do an aggregation. They'd want to know what the latency of a given service was, and so they'd do job equals service name, put it in a histogram contant and get the latency, and then not understand why their change didn't make any difference. What we found people were doing was they were basically aggregating the particular job across all three environments, dev, staging, and prod. And this was confusing people. This was a common mistake people made, and so we wanted to do something that meant you couldn't make this mistake. We wanted to put something systematically in place to prevent this kind of problem. So what we did is we expressed, as an organization, we expressed our opinion that the job name should contain the environment in which it's running. So all our jobs are prod/whatever, dev/whatever. And this, whenever you're selecting by job name now, this stops you accidentally aggregating across multiple environments. So we express these opinions with our relabeling rules, and that's kind of important, and you'll see why that's important in a minute. So Loki's data model is very similar. We use an identifier. It's literally exactly the same identifier you get in Prometheus. And then we use time indexed, but this time instead of numbers, we use bytes. We just treat the logs as bytes. We had to make a few changes, so our timestamps are nanoseconds, and apparently they're floats. That doesn't sound right. Our timestamps are nanoseconds because people tend to log quite quickly, log more than once a millisecond. But our identifiers are identical. And we use this system called Prometheus that we've developed. This is our own agent. It runs on as a daemon set on Kubernetes. It runs basically on every node. It runs Prometheus service discovery, embeds exactly the same code using Prometheus as a library to discover what pods or other applications you've got running on your host. And then it applies the same relabeling rules, and that's key. Because we've got the same metadata from Kubernetes, we've applied the same relabeling rules, and we've ended up systematically with the same set of labels to identify a target. And why is that important? You could, I've seen people try and attempt this in the past with things like FluentD and Logstash, where they arrange that FluentD and Logstash add the same metadata that you might see in your monitoring system. And you end up with a nice big config that says, oh, I need to subtly rewrite the metadata associated with this pod so it looks like this, so it matches what's in my monitoring system. By using the same code base, by using the same code, the same service discovery, the same relabeling rules, the same config, Prometheus systematically guarantees that you have the same metadata. And so the target labels associated with a log stream and with a metric will be the same. And that means for a single query, this is the worst screenshot in the world, I do apologize, but for a single metric query, we can identify the log streams that came from the jobs that produce that data, those metrics. And we can do this automatically. And you'll see in the demo, that means we can build this new workflow where you don't have to ever copy and paste and you don't have to ever translate your own queries, and it just works out the box, and it's guaranteed to work out the box. And this is what I was trying to achieve. And you can see there's a big, distributed tracing is still Zipkin. We've got some work to do still. We really want to integrate kind of tracing into Grafana as well and bring a very similar workflow there. But there's only so many hours in a day. Yeah, great. So, final point, cloud native and airplane friendly, or airplane mode. So you've seen this architecture, I showed you it before. We built Loki as a single binary, or split between an agent and the Loki server. And this is because I have to travel a lot now, unfortunately, and I'm normally not connected to the internet when I do. So I really wanted to be able to develop this on my laptop. I really wanted to be able to run it and test it and have that tight feedback loop without having to deploy a massive set of microservices. I mean, the real story kind of behind this is I wrote a system called Cortex about 3 years ago. And Cortex is a horizontally scalable version of Prometheus. And at the time, we were experimenting with all these cool concepts like microservices and cloud native this and container that. And we wanted to do all of that in Cortex, and use it as an opportunity to learn about the trade-offs of these kind of architectures. So we built this massively complicated architecture. I mean, Cortex probably has 15 different microservices that you need to run and orchestrate and get them all to talk to each other before you can have a running system. So I'm really proud of Cortex. Like, we run it at massive scale. It backs our hosted version of Prometheus. It's a CNCF project. A whole bunch of other companies are using it now. But having to orchestrate 15 different microservices was definitely a barrier to the adoption of Cortex. I think if I'd put more time and effort back then into Cortex to make it easy to run, make it so you could run it on your laptop, I think it would have helped the adoption. And so this is why we did it with Loki. We wanted to make it easy to run and easy to adopt, because it's open source, right? We want people to use the code. It gives me the warm fuzzies when, like, I see other people come up to me and say, hey, I use Loki, and it's really awesome. So what's more, like, this is not just a demo. The single binary, single process version of Loki is scale out. You know, you can horizontally scale it, you can use cloud storage with it for long-term retention, and you can really push it to quite high, you know, high workloads. Like, we're running 2 terabytes through Loki at the moment. But if you do like microservices, if you have the proficiencies internally to orchestrate 15 different services together to produce a single application, you can still run Loki in that mode. You can still, this is the Cortex architecture, but as Loki and Cortex are kind of tied at the hip using the same code, it's the same as the Loki architecture. You can run these 15, let's guess, different microservices, and this gives you certain advantages. You know, this allows you to isolate failures in the query path and failures in the write path. You know, it helps you improve your durability. Also, like, if you have particularly, if you have different workloads between queries, reads, and writes, you can scale independently the query path from the write path, which is kind of cool. So if you have a new customer come along who decides to ask queries that involve 10 terabytes of logs each day, you can just scale up your query path to deal with that. But it's optional. You don't have to run Loki like this. You can run Loki as a single binary, and you can get started with it today, and you can experiment with it, and you can, you know, scale out that single binary. So that's really the 3 things I think that makes Loki different. I wanted to give you a quick demo, so you believe me. Let's see if the demo works. I've been having some problems with the Wi-Fi, and if it doesn't work, it's definitely the Wi-Fi's fault. So I have the show mirroring options in the menu bar on, but it doesn't show in the menu bar. It's really annoying. Anyway. So we're all familiar with Grafana, apart from 2 of you.
Oh, you didn't say no.
So what I'm going to do, we've built a little demo app. I like giving demos, especially when they go correctly. This is all open source. You can go and look in Grafana TNS demo and see what we've done. But I always want demo apps to actually do something. I hate it when they're just like a load generator plugged into something that occasionally errors. So I wrote this demo app to be a clone of Hacker News with some reasonably, supposed to be a joke, by the way. This is not real news. But, you know, you can actually, like, you can upload it, you can upvote things, and the links even work. So yeah, you know, so there's a real app behind this, right? Even if it's a bit of a joke. So we built, you know, as with every good monitoring vendor will tell you, we built monitoring to go with our demo app. And so here you go, there's a load balancer and an app, and oh no, there's some errors. How's that happening? So this part is a bit fake, obviously. We've just got a timer that fails every 5 minutes. But we're going to try and use Loki to get to the bottom of this error. So we can see first, you know, I can see the errors are all the way down in the database tier. And we can go and explore that. Don't know what that means. And this way you can see it's not working. Let's just try that instead. Yeah. This way you can see, we're running like master of everything here, so it tends to break occasionally. This is how you can tell it's a real demo. Anyway, this is the Explore view in Grafana. If you haven't seen it already, it came out in 6.0. It allows you to fiddle with queries. So one of the nice things we can do is kind of use this to drill down. And you see how when I clicked on 500 down there, it went and put a filter for 500 into the selector. We're really just aiming this at people who maybe don't know PromQL so much. You can also do things like it will give you tab completions when it works. It will give you tab completions, honestly. There we go. So you can do, you know, drill down into particular things. I'm going to blame this on the Wi-Fi. Am I on the speaker's Wi-Fi? Yeah, I am. Yeah. Anyway, then the next thing you can do, you can kind of focus in on a given time range, and this is where the magic happens, right? You can up here switch to the Loki data source. Oh, don't ever do demos on master software. Here we go, it's working. And there, you see we've taken the labels from the query, and we've translated them into a set of labels that work for your logs automatically, and shown you the logs for this error about that time. You know, and there's a lot going on here, so I might just want to... That's excellent. Just what I need. So you can filter this down using, and this, you know, any of these kind of pipelines of filters, you can nest them, of course, but any of these pipelines are just basically doing a distributed grep. You know, we push the filter down as far as it goes to the leaves. There we go, you can see it's kind of doing this. And then, you know, we've done some kind of neat features when they work. Like one of the things that's really quite common is, you know, you might search for the first error, but you want to see the rest of the stack trace. Like a lot of people ask me how Loki handles things like multi-line logs, and I tell them we don't. We instead have this feature to show you context around the error, which is obviously not working because I'm running master. Oh, there we go. Shows you context around the error. You can also do, this is quite cool, you can do kind of some ad hoc analytics in the browser. What else can we show you with here? We've added a recent feature. So when I said that the labels that come in Loki come from service discovery, I kind of told a little bit of a lie, because you can also add labels from the logs. If you do something like structured logging and you know that your log level is going to be in a particular format, then you can, as we ingest the logs, extract the log level out, for instance. It's just regex matching. You can do whatever you like, but we do log level here. So obviously that's a bit facetious now because you can see we've only showing logs this way. And this way we're doing the lookup in the index, so it's faster. You want to be a bit careful here, though. We're using the same index as Prometheus, so all the same restrictions about cardinality and everything still apply. Don't put user IDs in the index, basically. Yeah, and that's... last thing I want to show you. This is the most requested feature when we launched it, was live tailing. Like everyone loves their kubectl logs-f. And so we've added live tailing. I think you got here. I'm just going to zoom out a bit so you can see more. And then, do you think the Wi-Fi will sustain a WebSocket? Probably not. Well, it works. Trust me on this one. It works better when there's better internet and you're not running the master of everything. We've got, you know, we launched Loki about 6 months ago. People asked us for live tailing. People asked us for metrics, extraction of labels into the index. People asked us for live tailing. We've kind of bit by bit been doing these. And one of the things I did want to tell you here, I haven't had a chance to put this in my slides, so I'm just going to go straight to the GitHub, is we've done our first release. So 0.1, after 7 months of release, we've released the first beta of Loki. So if you want to try it out, this is the big request everyone has always had. When are we going to have a versioned release? We're probably going to be bumping this pretty regularly, probably every month or every 6 weeks, until we get, you know, more stable and get to a proper GA version. But I'm hoping that will be in the next few months. Right then, let's whistle through the last few bits. So what are we doing next? We really want to, you know how I talked about Loki, you know, brute forcing expressions, and really right now all we can do is filter stuff down and do brute force search. I really want to start doing things like extracting metrics from logs. So we've got some basic support for that right now, but I really want to get to these kind of things where you can, you know, count the number of occurrences of error in your log and, you know, break that down by log level or by some other metric, by some other metadata, you know, and chain filters together and do it in a really kind of PromQL-esque way. One of the things we really want to do is be able to combine this data with data from the metrics as well. So be able to divide, let's say, the count of the number of errors in your log by the number of requests you're getting through your front-end metrics. So this is what we're working on right now. I'm hoping the first kind of version of this will be ready in the next few weeks. We've added the chained expressions you can see here. They're already in. But the rates and sums and binary arithmetic on your logs, that's something we're working on right now. We want to use that feature. Something people ask us for all the time is like we want to do alerts off of our logs. I tell people that's a terrible idea. But unfortunately, like, there is a whole bunch of software out there that isn't instrumented with metrics, that only exposes its error state through logs. And so I guess like not everyone lives in a world where they can go and instrument their programs, and therefore we have to allow people to alert off logs. But I'm hoping like we can use those aggregations and that logQL expressions that we've done to effectively reuse the whole Prometheus alerting system. So instance queries, alerting rules, alert manager, all of this kind of pipeline, to give you the same kind of alerts you might get from a metrics pipeline. This was, I was at KubeCon in Barcelona 2 weeks ago, and a chap came to the booth and said, I really, really want signature chaining so I can show that like the logs haven't been forged and haven't been tampered with. And I was like, now I can actually think of a use case for blockchain. Sorry. We have this dependency on a NoSQL store for your index. So when we run this in Google Cloud, we use Bigtable. A bunch of people use DynamoDB. We've added the support for a local BoltDB instance, so you don't have to have that dependency. But it's still kind of maybe not 100% production worthy yet. So we want to completely remove the dependency on NoSQL and productionize the BoltDB index. And we think that's going to be like the final step before like basically Loki is ready. And then, yeah, launch the first beta. Well, we've just launched it, so great. Thank you very much. So who has questions? I think I've got a few minutes. I have 4 minutes for questions, so hands up. Anyone? Go on, someone kick it off. If I'm missing anyone up there, you'll have to shout. Go on then, first one.
Can you have a high cardinality label that's not indexed that you could use at a later stage for analysis?
Yeah, can you have a high cardinality label that's not indexed? That's kind of just the body of your logs, right? Is incredibly high cardinality. So the thing we want to do is be able to extract stuff from the body of the logs to use in labels at query time. I think that will work pretty well. We haven't done it yet. I think that will work pretty well and will get you kind of most of the way there. But if you're going to extract like, IP address and client port numbers out and stuff like that, you're going to have a bad time. We're going to have to do a lot of work to make that so the query engine can deal with that kind of workload. But I think there's, unlike something like Prometheus, where the answer would just emphatically be no, I think there's room in this kind of system to accommodate that kind of thing. I think at the end of the day, though, you're never going to use this if you're thinking of using it for kind of like analytics or BI. Yeah, never going to use it for that. This is for developers for finding stack traces. Who's got another question in the middle here? Are we going to do a Docker logging driver? I mean, it's open source, man. PRs are welcome. So currently we actually work with Docker logging because we just tail log files on disk. We thought that was the most generic way of integrating with things. I don't know enough about Docker logging drivers, and Kubernetes is probably not going to be using Docker for a lot longer, right? It's going to be using Containerd. So I don't know. It's open source. It sounds reasonable. It sounds like something that we might do. We're more interested right now, I guess, in things like journal cuttle integration. We've got a FluentD driver. I think we're working on a logsbeat driver. Beat logs, something like that, yeah. So yes, I don't have any plans to do it right now, though. Any more questions?
Will you open source Grafana News?
It is open source. Seriously, it's already on there. Like, please just go and open PRs for more inappropriate content. TNS demo. Oh no, where is it? Famously not open source. TNS, there you go, it's already there. There's actually a lot of history to this. Like, we built this ages ago, but TNS means the new stack, which is this paper, this online thing that we built a demo for, probably 4 years ago now. And slowly we've been evolving it and tweaking it, and the latest stuff is Grafana News. So. Cool. Any more questions? I can't see any hands up, so if I've missed you, I do apologize. Come and catch me afterwards. Thank you very much.